some of our calorimetry data. So in this lab, you're going to get a whole bunch of measurements. You're going to measure the mass of the calorimeter, that's just the coffee cups with the lids, and then you're going to put some room temperature water in there, and then you'll measure the temperature, you get the mass. Then you'll do the add some hot water in there, get the mass of that, get the final temperature, the mass of your initial temperature of your hot water as well, and then you have to do some calculations. So let's jump into some of these calculations. You should have already collected all the data that's in red. Okay, and then this is a constant, so the heat capacity of water, specific heat of water, is going to be 4.184. We're going to need that. So the first thing, mass of the MRT just means the mass of the room temperature water. So if you have mass of the calorimeter with room temperature water and you have the mass of the calorimeter empty, if you just subtract those two, you should get where you want to go. So I'm going to do 15.55, whoa, minus 5.53, and that should give you 10.02. Now, of course, your numbers might be a little bit different. Delta T, the room temperature water, you need to look at the delta T is always final minus initial. So if we're looking at delta T of the room temperature, we're looking at the final temperature and subtracting out the room temperature water. So 45 is my final temperature, and my room temperature, my initial room temperature water was 24. All right, so I've got 45.0 minus 24.0, and that should give me, what, 21 degrees? Yep, 21 degrees Celsius. Awesome. And then we want to find the Q, the heat of the room temperature water. So Q equals MC delta T. So I want the mass and the delta T for the room temperature water, and the specific heat capacity of water is just this constant over here. So MC delta T is just going to be the mass that I just found at 10.02 times heat capacity, 4.184. Let's look at our units on here too. So this is in grams, this is in joules per gram degree C, and then my delta T here is going to be in degree C. So it's the delta T that I just calculated there was the 21. So when I work all that out, I get, need more room. I got 880.397. Oops, and my units here, my Celsius cancels, my grams cancel, and I end up with joules. All right, so this one's just Q equals MC delta T. Just make sure you calculated your delta T correctly and your mass, and you're good to go. Now, mass of the hot water. Well, how did we find the mass of the room temperature water? We took the difference of two things. So for hot water, if we know this 15.55 represents the calorimeter plus the room temperature water, and then we added 10 mils of the hot water to it, and then we found the mass again. So if I take the difference between these two, I should get the mass of the hot water. So I'm going to do 23.99 minus the 15.55. That becomes 8.44. That's in grams. Delta T, again, is final minus initial. My final temperature was the same for both of them, right? Because that's how I know when I'm done. So that's 45 minus my initial was 75. So I'm going to end up with a negative change in temperature here, which kind of makes sense because it was hot water and now it's getting colder. So that water's leaving. So that's my change in temperature. And now to find the Q hot, I need the M hot, the delta T hot, and then the C of the water is still the same. That's a constant for all the water. It doesn't matter what the temperature is. It's always the as long as it's in the liquid phase. If we had other phases, it would be different. But this one, we have liquid water. So MC delta T, so my mass is 8.44, that's in grams, times the 4.184 joules per gram C. And then my delta T here is the negative 30. So I end up with negative 1059.389 joules, which is telling me that heat is leaving the hot water, right, and going into the room temperature water. And some of it's going to be lost to the calorimeter. So that's what we want to find next, is like how much heat is being lost to the calorimeter. So if you think about what we're doing here, we have a certain amount of heat in our system. We're going to have Q hot. We're going to have Q room temperature, and some of the heat will be lost to the calorimeter. So all those heats have to equal 0. I already know two of these, right? I just figured these two out. So what I'm going to do is just subtract these and bring them on the other side, and that's how I'll solve for Q hot, right? So I'm going to just do this, just deriving this equation a little bit, which they do in the lab manual. So I'm just going to subtract this part, bring it over here. So I have Q cal is equal to negative Q hot plus Q RT, right? That's where we got this equation from, in case you were wondering. So I just need to do negative of, adding these two numbers. So you can see that if they were equal, if the total amount of heat lost by the hot water was picked up by the room temperature water, then the calorimeter constant would be 0, right? We wouldn't, but they don't add up. So there's a certain amount of heat that's being lost to the calorimeter. All right, so I'm going to add these two up. We've got 880.397 plus negative 1059.389. And when I work that out, you get 178.992 joules. Okay, they're both in joules. Joules. And then C-cal is Q-cal divided by delta T-cal. So now I can find the C-cal, and you're going to need that for the next, for part 2. So Q-cal, that's what I just calculated there. That's my 178.992 divided by the delta T, the cal, and they give you this note here that delta T-cal is the same as the change in the room temperature. So the delta RT, so that's that 21. So divided by 21 just gives me 8.523. So that is the calorimeter constant, and we're going to need that for the next section. So I'm going to take that number, I'm going to copy that, and I'm going to throw that in my table so that I don't forget where I got that from, over here. So where it says C-cal, that's a constant now that I got from the first part. Now in the second part, what you're going to do is you have a large washer and then you have a small washer. So you can take that large washer, you're going to do 3 trials with it. I'm only going to show you the workup for 1 trial. And then you take the small washer, do the same thing, 3 trials of that. So this is all the data that I collected for this trial. I have the mass of my metal, which I don't really need until the very end. I got the mass of the cups, and I've got the mass of the cups plus water. So in order to find the mass of the water, oh, that wasn't cool. Let me make some space here. All right, to find the mass of the water, I want mass of the cups plus the water minus the mass of the empty cups, so 14.04 minus the 4.17. That gives me 9.87 grams. Okay, that should really be in green. All right, so I calculated that. This was my initial water temperature. This is my initial metal temperature, right? Remember what we did? We put it in boiling water. You put that little piece of metal in boiling water until it equilibrated to that temperature. So your initial temperature for the metal should be 100. Your final temperature after you put them together is whatever it is. You wait until it stops changing, and then there you go. So the delta T of the metal is just the T final minus the T initial for the metal. So that is T final. T final is 26.5. And initial for the metal is 100, so I'm going to end up with a negative number there again, which should make sense because heat is leaving the metal. Delta T of the water, on the other hand, should be going up, right? So I started off with 21, I ended up with 26.5. So final is 26.5 minus the initial, which is 21. And that should have been recorded as 21.0. Right, so my delta T of my water is 5.5. The T-cal of the water is the delta T, the change in the calorimeter temperature is the same as the change in temperature of the water. So we'll just copy that down again. That's 5.5. The C-cal, that came from table 1. So make sure you calculated that in the first step. It's that last piece over here. You're going to bring that down here. So that's going to be different for everybody, and it's from table 1. And then C-cal is, Q-cal is C-cal times delta T-cal. So that's my C-cal. 8.523 times my delta T-cal, which is right there, is 5.5. And that is 46.879. My Q, my water, so again, Q, MC delta T, so MC delta T, so I have my mass of my water, which I found in the first step, right? This is my mass of my water, 9.87. The CW is the same as it was before, right? It's that constant. C water is 4.184. And sorry, again, this is in, just look at your units, grams, and this is joules per gram C. And then my delta T in my water was 5.5. That's in Celsius. So I'm going to end up with something in joules. And I got 227.128 joules. What else do I have here? This one. Q, so again, just like we did last time, Q, all these Q's have to equal 0. Q cal plus Q water plus Q metal. I know what these two are, so I'm going to add those up, put a negative in front of it, and then that should give me what my Q metal is. So again, similar to the idea what we did over here, adding up all these Q's has to equal 0. Now let's solve for the Q of the metal, because we don't know what the specific heat of the metal is. So we couldn't just do this Q equals MC delta T. We don't know what our metal is, so we don't know what the specific heat is. That's what we want to solve for. So if we know the Q of the water, that's what we just calculated over here. That's 227.128 plus the Q of the calorimeter. Right here, Q cal, that's the 46.879. And when I put those together, I end up with negative 274.007 joules. That's the Q of the metal. And then to find the specific heat of the metal, again, I'm using Q equals MC delta T, Q equals MC delta T. I don't know what C is. That's what I want to solve for. So I'm going to divide both of them by M delta T, M delta T. So now I have my Q. So Q over M delta T should give me the specific heat. So that's where we got that equation from. So this is the Q we're looking at. We've got negative 274.007. That's in joules, divided by the mass of the metal, 4.15 grams, times the delta T of the metal, which we found over here, delta T metal, negative 73.5. So when you work that out, you get 0.8. Oh, what did I get? Yep, 898 joules per gram C. So you'll do that with a bunch of other data here. So you'll have trial 2, trial 3, follow that process again, get that data, work through the calculations, and then just add those three numbers up, divide by 3, and you'll get the average. And then once you have the average, you can go down to the very end of this table here and then look up your value. So look up the specific heat, and that'll tell you what metal you have. So I had 0.898, so the closest I would have here was aluminum. Aluminum's 0.9, I got 0.898. All right, so identify your unknown. And then make sure you write that in your abstract and in your conclusions, what you identified the unknown washers to be made of.